Okay, so here we're trying to find the center of gravity. We know that 11 minus x squared is the f, and then x squared plus 3 is the g. So in order to find the bounds, we're going to have to set them equal to each other. So 11 minus x squared equals x squared. Why is that being written all weird? Equals x squared plus 3. So by doing a little algebra, you're going to end up finding out that the bounds through making the x's equal to each other and the 11 and the 3, and then x squared equals 4, you're going to end up with -2 and 2 as the bounds. Next, you're going to want to draw the graph. So for the graph, we know that it's going to have a peak at 11 because 11 minus x squared, and it's going to also have another one of its peaks, I guess you could say, at 3 because x squared plus 3. X squared plus 3 is positive, however, so this one's going to go up, so it's going to look like this. And the bounds we just found are -2 and 2, so it's going to start from here, which is the 2, right? And then go like this, staying within the bounds. With the 11, it's going to slope down because it's negative, so it's going to end up looking like this, within the bounds. Right, like that. We're trying to find this area. So we've accomplished, we sketched the region R, so we got some points for that. Step 2, now we're going to find the moments. So first we're going to start with the moment X, which looks like this. Well, it's like the moment Y, I guess, but it's like, it's this shit right here. So M as the integral goes from A to B, there should be an x right here for the x. There's a 1/2 for the y, but for right now, just focus on this x. And then you're going to have bound like with the x times the function f of x minus g of x. With y, there should be squared right here, and then dx all over the area, the equation for the area, b to a. So you're going to draw another integral. And you're going to do this one separately. So it's going to be done separately. But this is just a regular function, so it doesn't look as funky as the others. F minus g of x. So now that we have the integral, we're going to set it up. So we're just literally going to plug in everything that we found. So we found the bounds is -2 to 2. So we're going to put -2 to 2 with x, literally x, just x, times f of x. And it's usually like bigger minus smaller, but for this one you don't have to worry about it. Just plug in x as f as is. So 11 minus x squared minus g of x, which is x squared, plus 3, right? Bounded, and then dx. So once you've successfully subtracted 11x by 3, x squared plus 3, you should end up with something similar to this, where it's like 8 minus 2x, 2x squared, but then you're going to distribute the x into it after, because the x is outside of the parenthesis of these two functions, right? Like where I'm pointing my pencil at. So it's going to be done after, right? So it's going to look something like this. The integral 2 to -2, 8x minus 2x cubed. And then you're going to take the antiderivative, which is going to equal it's going to be 8x squared over 2 minus 2x to the 4th over 4 with 2 and -2 as the bounds, right? So to set up this integral, you're going to plug in 2 first, so 8 times 2 squared. I like to do it as is so you can take away any confusion. And then 2 with 2 squared, 2 to the 4th, I meant to say, 2 to the 4th over 4, right? And this is going to end up being